Hello my dear students, once again I am here. This time we are going to start a new chapter. Name of the chapter is limit. So what is a limit? How limit will be used in your book, that we will discuss. Look at this function first of all. You have studied function, a chapter function. Let's have a look at this function. X square minus 2 upon x minus 2. So if in this function, if we substitute x as 2, if we will substitute x as 2, what will happen? This will become 4 minus 2, sorry, x square minus 4, it is x square minus 4. So if it is x is equals to 2, then it will become 0 upon 0, and 0 upon 0 is called a indiscriminate forms. So at x is equals to 2, the value of this function is indiscriminate. But if it except x is equals to 2, the value will be x plus 2 and x minus 2, and then x minus 2 will be cancelled. So the value will be x plus 2. Now look at, so if x is equals to 2, then its value will be 4. At x is equals to 2, the answer is 0 upon 0. And other than x is equals to 2, if I am taking, these are the values of x and these will be a value of fx. If I am taking f 1.5, then the value of fx will be 3.5, 1.6, 3.6, 1.7, 3.7, 1.8, 3.8, 1.99, 3.99. So in the left hand side of 2, if the value is increasing, if the value of x is increasing, the value of fx is also increasing. At x is equals to, if the value of x closer to 2 is, then the value of fx is closer to 4. Similarly, in the right hand side, if it is 2.5, then the value of function is 4.5, 2.4, 4.4, 2.3, 4.3, 2.2, 4.2, 2.01, then 4.01. So in right hand side, what we are saying, what we can observe, that when the value of x is decreasing, at that time the value of fx is coming closer to 4. So this left hand side, when value of x is increasing and value of fx is coming closer to 4, this is known as left hand limit. This is known as left hand limit. And how do we represent it? We represent it limit x tends to 2 minus fx, or we can call it LHL, left hand limit at x is equals to 2. Similarly, we will calculate the right hand limit. The right hand limit is represented as limit x tends to 2 positive fx, and this is known as RHL at x is equals to 2. And when left hand limit is equals to right hand limit, when left hand limit will be equals to right hand limit, that time we will say that limit at limit x is equals to 2, fx exists. Fx exists. And if LHL is not, if LHL is not equals to RHL, then we will say function does not exist. Okay. So how we will use this LHL and RHL, how we will calculate the left hand limit and right hand limit of a function, that you should understand. Okay, I hope this is clear. Now if there is a function and we want to calculate its left hand limit, then what is the procedure of it? How it will remain same. The procedure will remain same for all the things. So it will involve a few steps. For example, if we are having limit, if we want to calculate LHL, left hand limit at x is equals to x minus a fx. Then what will we do? In place of a, I am going to substitute a minus h. A minus h. Okay. Then what impact it will have? If a minus h, since x was a, so h will be 0. H tends to 0. So then I will do limit h tends to 0 f a minus h. Find the value of the function f a minus h at h tends to 0. That will be your LHL. Similarly, for RHL, what you will do? Limit x tends to a positive fx, and when x tends to a, and I am substituting x as a plus h, it will become, replace a, x tends to a as h tends to 0, it will become limit h tends to 0, find the value of function f a plus h. That will be the RHL of the function. And if LHL and RHL are equal, then we will say that the function exists, otherwise the function does not exist. Let us have few examples of finding left hand limit and right hand limit. Okay, so what you will have to do? In left hand limit you will have to substitute a minus h, in right hand limit you will have to substitute a plus h. If the limit was x tends to a, later on it will become h tends to 0. If the limit was a positive, then also it will become h tends to 0. Evaluate the left hand limit and right hand limit of a function. The function fx is given as x minus 4 upon x minus 4 at when x is not equals to 4 and 0 when x is equals to 4. At x is equals to 4. We will have to find LHL and RHL at x is equals to 4. So what I am going to calculate LHL at x is equals to 4. So what it will become? Limit x tends to 4 minus fx, or I will say limit h tends to 0 f 4 minus h. Now what I am going to do, in place of x I am going to substitute 4 minus h in the value of the function. So it will become limit h tends to 0 modulus 4 minus h minus 4 upon 4 minus h minus 4. 4 से 4 cancel, 4 से 4 cancel. Due to modulus, outside I got positive h, and from the bottom it is negative h. I got limit h tends to 0 negative 1. So the answer is negative. So LHL at x is equals to 4 is, the value of LHL at x is equals to 4 is minus 1. Now I will calculate RHL at x is equals to 4. He is simply asking LHL and RHL. Okay. Then limit x tends to 4 positive fx, which will become limit h tends to 0 f 4 plus h. Now in the function substitute x as 4 plus h. So 4 plus h minus 4 upon 4 plus h minus 4. 4 से 4 cancel, फिर से I got limit h tends to 0 h upon h. So the answer is limit h tends to 0 positive 1, and hence the answer is positive 1. So LHL is negative 1 and RHL at 4 x is equals to 4 is positive 1. So this way you will get some questions like this, in which you will have to answer LHL and RHL, or he will ask that function exists or function does not exist. Okay, so let us start few more examples. This was the first one. Then let us see the next. You will get function, you will have to calculate LHL and RHL and then the value what he is asking for. So what he is saying, evaluate the left hand and right hand limits of the function defined by this at x is equals to 1. Also show that limit x tends to 1 fx does not exist. The function does not exist. The function does not exist, it means the value of our LHL and RHL is not going to be same. Then we will have to find their value and then we will see that they are not same. So question number 1, fx is given as 1 plus x square if x is greater than equals to 0 and less than equals to 1. So till 1 we will use this function, and 2 minus x 1 plus x square, sorry, 2 minus x if x is greater than 1. So what does this mean? Iska kya matlab hai? Look, our left hand side will use at x is equals to 1. At x is equals to 1. In left hand limit, we will use 1 minus h. So we will use something lesser than h. So when x is lesser than 1, the function will be this. And in our RHL, it is 1 plus h. So it is more than 1. And so when x is more than 1, we will use this function. So the use of this is this, that when we will use this for the value of the function and when we will use this value of the function. So LHL at x is equals to 1 will give us limit x tends to 1 minus fx, that is limit h tends to 0 f 1 minus h. So at 1 minus h, it is smaller than 1. So when x is smaller than 1, we will use this function. So in this, substitute x as 1 minus h. 1 plus 1 minus h ka whole square. What I got? I got limit h tends to 0, 1 plus h square minus 2h. So I got limit h tends to 0, 2 plus h square minus 2h. Now in it, substitute h as 0. So when I will put h as 0, this will also become 0, this will also become 0, and the value of the function will be 2. So LHL at x is equals to 1 is 2. Now I will calculate RHL. RHL at x is equals to 1. Right hand limit I am going to find out. Limit x tends to 1 plus. So fx is equals to limit h tends to 0 f 1 plus h. This is RHL. So 1 plus h. 1 plus h is more than 1. Here we are having this value up to 1 is equals to 1 पर भी ये use करना है. But when x is more than 1, we will use this function. So in this function, substitute x as 1 plus h here. I got limit h tends to 0, 2 minus 1 minus h. This becomes limit h tends to 0, 1 minus h. H is 0, so I got 1. Since limit x tends to 1 minus fx is not equals to limit x tends to 1 positive fx, so limit x tends to 1 fx does not exist. So this way we will calculate the LHL and RHL, and then we will conclude that the function exists or function does not exist. So this was question number 1. Let us see question number 3. Same way it is, nothing new. What it is saying, fx is equals to 5x minus 4 and 4x cube minus 3x when x is between 0 and 1 and when x is more than 1. So you will have to show that limit fx exists at x is equals to 1. At x is equals to 1 fx exists. ये बताना है. So we will have to calculate LHL at x is equals to 1. What I will get? Limit x tends to 1 minus fx, that is limit h tends to 0, h tends to 0, f 1 minus h. At 1 minus h the function will be this. So limit h tends to 0, 5, in place of x I am putting it 5 minus 5h minus 4. I got limit h tends to 0, 1 minus 5h, that is 1. So this is the value of our LHL. Now let me calculate RHL at x is equals to 1. I got limit x tends to 1 plus fx, that is limit h tends to 0, f1 plus h. It means limit h tends to 0. At 1 plus h, I will have to substitute this here. So 4 into 1 plus h whole cube. It will be 1 plus h cube plus 3h square plus 3h minus 3 minus 3h. Okay. So now let me multiply 4 inside. Limit h tends to 0. Or you will not multiply, then also it will go. Then what will happen? Wheresoever it is h, that will be 0. So this will be 0, this will be 0, this will be 0, as well as this will be 0. The only thing left is 4 minus 3, that is 1. So I will come to know that this way the LHL at x is equals to 1 and RHL at x is equals to 1 are equal. So the function exists. So limit x tends to 1 fx exists. This way we will conclude this question. Now and look, sometime what will happen, he will ask you the value of some unknown. So that unknown value you can say, let us see this in question number 5. Question number 5. Yes, what it is saying that fx is given as, and at x is equals to some at x is equals to 0 fx exists, then find the value of k. Fx is equals to cos x at x greater than 0 and x plus k when x is less than 0. Find the value of constant k given that limit fx tends to 0 exists. He is saying limit x tends to 0 fx exists. Exist means LHL at x is equals to 0 is equals to RHL at x is equals to 0. So limit, let me calculate LHL. So limit x tends to 0 fx is equals to limit h tends to 0 f0 minus h. So 0 minus h means this the value of x is less than 0. So for less than 0 we will have to put it here. In this I am going to substitute x as 0 minus h. So limit h tends to 0, 0 minus h plus k. If I substitute h as 0, the value of the function is k. Similarly, RHL at x is equals to 0. It will become 0 minus, it is limit x tends to 0 plus fx limit h tends to 0, f 0 plus h. So when x is more than 0, when x is more than 0, its value is cos x. So in cos x, substitute x as 0 plus h. Cos 0 plus h. H is 0, so it is cos 0, and cos 0 is 1. And since LHL at x is equals to 0 is I equals to RHL at x is equals to 0, so I got k is equals to 1. Since both of them are equal, so I will keep them equal, keep their values equal, so I will get the value of k as 1. Sometimes you may get a double equation here. So by solving the linear pair of equations, you will get the value of unknown. As it is happening in example number 9. So let us see example number 9 now. What he is saying, fx is equals to a plus bx for a plus bx when x is smaller than 1. When x is equals to 1, the value of the function is 4, and when x is greater than 1, it is b minus a. चलो क्या कह रहे हैं? If limit x tends to 1 fx is equals to f1, what are the possible values of a and b? What is given? Limit x tends to 1 fx is equals to f1. So when f1 is there, the value of the function is 4. The value of the function at x is equals to 1 is 4. So f1 is 4. And what is given? That it is equals to function limit x tends to 1. So it means that limit x tends to 1 negative means LHL and RHL is equals to f1. The meaning of this is this. So one equation we will get by left hand limit and f1, another equation we will get from right hand limit, and then by solving that we will get the value of a and b. Chaliye, let us calculate LHL. At x is equals to 1, so limit x tends to 1 fx, then I got limit h tends to 0 f1 minus h. So when x is less than 1, the value is here. So here's in this substitute a as x as 1 minus h. So limit h tends to 0 a minus b minus bh. Okay, now I substitute h as 0, so I got the value as a minus b. And f1 is 4, so when I will keep them equal, my first equation is a minus b is equals to 4. Similarly, RHL at x is equals to 1, 1 negative, 1 positive, I will go calculate here, 1 positive, fx, that is limit h tends to 0 f1 plus h, limit h tends to 0. Now value of x is more than 1, so at x is more than 1, I the value of the function is this. So in this in place of x substitute 1 plus h, that is b minus a minus h, and when h is 0 I got b minus a. And here also this is there, that limit 1 x tends to 1 positive fx is equals to f1 as it is mentioned here. So b minus a is equals to 4. Now what should I do? A minus b and b minus a. Some mistake is there? Yes, some mistake is there. That it is b plus b. What it was, since it was plus, so it will be plus a plus b. So I got a plus b as 4 and b minus a as 4. Now let me solve it. On adding, I got 2b is equals to 8, so b is equals to 4. And when b is equals to 4, I got a as 0. So the possible values are A0 and B4. So this way we will solve our question number 9. Now let us see question number 10. In question number 10, he is discussing one thing which is called greater integer function. Greater integer function that you have studied in the chapter function. So when the greatest integer function is there, what happens? The symbol of greatest integer function is fx is equals to, in bracket, this is called greatest integer function. And when this is there, what happens? The value is k minus 1 when x is lying between k minus 1 and between k, and is k when the value of x is more than k minus 1 and less than k plus 1. More than k and less than k plus 1. This is the definition of greatest integer function. Okay, and in this what he is saying in question number 10, find the left hand and right hand limit of the greatest integer function, that is fx is equals to x, greatest integer less than or equals to x at x is equals to k, where k is integer. Also show that limit x is equals to k, fx does not exist. So fx does not exist, LHL or RHL निकालनी है, और when x does not exist, it means LH and RHL will not come equal. So in this question, only this much portion will be given. This you must learn. If you don't know this, you will not be able to solve question number 10. Okay, so this is the definition of greatest integer function. Now, LHL at x is equals to k. So limit x tends to k negative fx is equals to limit h tends to 0 f k minus h. So k minus h means it is the value of x is less than k. So in this case, the value of function will be k minus 1. In this, in place of k, I am going to substitute k minus h. Limit h tends to 0, k minus h minus 1. So the value of the function will be k minus 1. So the value of the function will be k minus 1. Similarly, in RHL, at x is equals to k, limit x tends to k positive, fx, limit h tends to 0, f k plus h. Now when it is more than k, it will lie here. So in this function, in place of k, substitute k plus h, limit h tends to 0, it is k plus h. At putting h is equals to 0, I got the value k. So the value of LHL at x is equals to k is k minus 1. RHL at x is equals to k is k, which is not equal, hence function does not exist. So I will write it like this: limit x tends to k negative fx is not equals to limit x tends to k positive fx. So limit x tends to k fx does not exist. Okay, this was the question number 10. This definition of greatest integer function is to be learned to you so that you can solve this question. Now let us see question number 12. What question number 12 is saying? Once again, you will have to check that RHL and LHL and RHL only, but the function is exponential. So what he is saying, show that limit x tends to 0 does not exist. Limit x tends to 0, e to the power 1 upon x minus 1 e to the power 1 upon x plus 1 does not exist. Okay. Now for does not exist means LHL and RHL should not come equal. So their values will be different. Okay, let us try to understand. LHL at x is equals to 0, it means limit x tends to 0, e to the power 1 upon x minus 1, e to the power 1 upon x plus 1. It means limit h tends to 0, and in place of, if we call it fx, in place of x I'm going to substitute 0 minus h. So 0 minus h is e to the power 1 upon 0 minus h minus 1, e to the power 1 upon 0 plus h minus 1. But before this, let me understand one thing. When h tends to 0, 1 upon h tends to infinite. 1 upon h tends to infinite. Very nice. Then e to the power 1 upon h is infinite, so it will be infinite. So 1 upon e to the power 1 upon h will be 0. So this you will have to understand, that when h to the h tends to 0, so 1 upon h will be infinite, and in that case e to the power 1 upon h will be infinite. In 2 to the power 2.7 to the power infinite is infinite, and in that case 1 upon infinite will be 0. So it is 0 minus h. What it will be? Limit h tends to 0, e to the power minus 1 upon h minus 1, e to the power minus 1 upon h plus 1, because 0 minus h is 1 minus h. And now 1 e to the power minus 1 upon h will be written as limit h tends to 0, 1 upon e to the power 1 upon h minus 1 and 1 upon e to the power 1 upon h plus 1. Now I am substituting h tends to 0, so this is 0, this is also 0, 0 minus 1, 0 plus 1, and hence the answer is minus 1. So this way I will substitute the limits in this. Now RHL at x is equals to 0, it means limit x tends to 0, e to the power 1 upon x minus 1, e to the power 1 upon x plus 1, that is limit h tends to 0, e to the power 1 upon 0 plus h minus 1, e to the power 1 upon 0 plus h plus 1. So it will become limit h tends to 0, e to the power 1 upon h minus 1, e to the power 1 upon h plus 1. Now e to the power 1 upon h is infinite, so that will create a problem. So what I will do, how I will solve it? Limit h tends to 0, I will write it 1 minus 1 upon e to the power 1 upon h and 1 plus 1 upon e to the power 1 upon h. You can understand it that I have divided both the terms by e to the power 1 upon h, then it will come in the picture. This will become 0, and hence 1 upon 1, the answer will be 1. And as you can see that the value of LHL is minus 1, the value of RHL is plus 1, hence the function does not exist. Limit x tends to 0 negative, fx is not equals to limit x tends to 0 plus fx, so limit x tends to 0, fx does not exist. So finish off your question till here. In our next exercise we will understand something else about limit. Till then, take care and finish off your work and keep preparing for your half-yearly exams.